Hi learners! In today's video, you will learn how to apply trigonometry in solving a real-life problem. It particularly demonstrates how to determine if a structure is safe for Mario to use by getting the measure of the acute angle created by the structure or setup using inverse trigonometric ratio. Solving for the angle measure from the trigonometric ratios and their inverses is demonstrated so that you will be able to apply these learnings in answering application problems on the topic. Strategies in analyzing and solving a problem related to the topic, together with how the calculator is used in getting the answer, are showcased to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to this in the future. If your lesson is on trigonometric ratios and its inverses, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you're someone who is interested in learning math, then this video is for you. Recall that trigonometry is a branch of mathematics that deals with the connections between the measures of the sides and the angles in a right triangle. These connections are expressed in the following trigonometric ratios. Sine A is equal to opposite side over the hypotenuse. Cosine A is equal to adjacent side over the hypotenuse. Tangent A equals opposite side over the adjacent side, where angle A is the reference angle as shown in the figure. For the detailed discussion on how to label the sides of the right triangle, watch the videos on trigonometric ratios. The link is down below. On the previous videos, we focused on solving for the sides of the right triangle using trigonometric ratios. In today's video, we will focus on solving for the acute angle in a right-angled triangle and use this learning in determining if a structure or a given setup is safe for use. With this knowledge, correcting the setup comes easy, thereby avoiding accidents to happen. How do we find the acute angle in a right-angled triangle using trigonometric ratios? It is simple. All you need to remember are the three trigonometric ratios. From this, we can solve for the angles by using the inverse trigonometric ratios. Here, we will set up the inverse trigonometric ratios so that you will know how to get these without memorizing the formula. Okay, with the sine ratio, which is sine A equals opposite side over the hypotenuse, we will set up its inverse by moving sine to the right side of the equation, giving it a negative exponent, and landing it before the ratio like this. We now have angle A equals sine to the negative 1 times opposite side over the hypotenuse. This is now the equation that will be used in solving for angle A when the opposite side and the hypotenuse are known. The same thing happens with cosine ratio, which is cosine A is equal to adjacent side over the hypotenuse. Its inverse is set up in the same manner. We move cosine to the right side of the equation, assign it with a negative exponent, and land it before the ratio like this. We now have angle A is equal to cosine to the negative 1 times the adjacent side over the hypotenuse. This is now the equation that will be used in solving for angle A when the adjacent side and the hypotenuse are known. The same thing happens with tangent ratio, which is tangent A is equal to opposite side over the adjacent side. Its inverse is set up in the same manner. We move tangent to the right side of the equation, assign it with a negative exponent, and land it before the ratio like this. We now have angle A is equal to tangent to the negative 1 times the opposite side over the adjacent side. This is now the equation that will be used in solving for angle A when the opposite side and the adjacent side are known. I hope you were able to see the pattern, learners. If you remember the three trigonometric ratios, it is easy to write the inverses of the ratios. Thus, solving for the angle measure would be easy. Now, let us try to solve for an angle in a right-angled triangle so we will know how it is done. Let's go. Here's the problem. Sample problem 1. Given triangle ABC, solve for angle B. A figure is given. Here are the options. Option A, 30.9 degrees. Option B, 34.8 degrees. Option C, 55.2 degrees. Option D, 60.2 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information helps find what we are looking for. What is asked in the problem, learners? You are correct. We are to find the measure of angle B. What are given? We are given a figure with two side lengths. Now, since our figure is a right-angled triangle, we will solve for the angle measure by first identifying the appropriate trigonometric ratio for the problem. We start by identifying the reference angle. Here, the reference angle is the angle that we are looking for, angle B. We will put an I where the reference angle is, just like what we did on our previous videos on trigonometric ratios. Then, we label the sides with given values. We label the opposite side, then the hypotenuse. Look at the labeled triangle this time. Of the trigonometric ratios, which one has the opposite side and the hypotenuse? Okay, so sine ratio. We will write the ratio. So sine B is equal to opposite side over hypotenuse. Next, we get the values from our figure and plug those in. Let's go. So sine B is equal to 4 over 7. Then, we write the inverse of sine, the equation above, to solve for angle B. Thus, angle B is equal to sine to the negative 1 times 4 over 7. Finally, we solve for this equation using a calculator. We will use a TI-84 calculator. Always remember to set the calculator to degree mode before using it. To set to degree mode, heat mode. This is what you see on the calculator screen. Heat down arrow to radian, then right arrow to degree. Here is what you see on your calculator screen now. With this on the screen, hit enter. Then clear the screen by hitting clear. The calculator is now ready for use. Again, the equation that we want to solve is angle B is equal to sine to the negative 1 times 4 over 7. Now type what you see on the right side of the equation starting with sine to the negative 1. For inverse sine, which is sine to the negative 1, activate the inverse sine by hitting second, then hit sine to the negative 1 on your calculator. This is what you will see on the screen of your calculator. Continue by typing 4, hit division sign, type 7, then hit the close parenthesis. You have this now. With the image on the screen, hit enter. This is what is on the screen now. Bingo, we have the answer. So, what is our answer, learners? Is it option A, option B, option C, or option D? You are correct. Option B is the answer. There you are. I hope you were able to get it, learners. Okay, let us work on this application problem this time. Sample problem 2. Here's the problem. The HSE, Health and Safety Executive, recommends leaning your ladder at a 75-degree angle to the ground for safety. Mario intends to use a ladder today. The base of a ladder that is 6.5 feet long is positioned a foot away from a wall as shown. Is the ladder safe for Mario to use? Explain your answer. So figures given. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information helps find what we're looking for. What is asked in the problem, learners? We are asked if the 6.5 feet long ladder that is positioned a foot away from a wall is safe for Mario to use. And we are to explain our answer. What are given? We are given the figure of the ladder with its length and the measure of how far it is positioned from the wall. As recommended, the angle between a ladder and the ground should be 75 degrees for safety. We will check if that is the case here. We will modify the figure by naming the angle that is created between the ladder and the ground as theta. We will determine the measure of the angle theta so that we will know if the given setup is safe for Mario to use. Now, between the wall and the ground is a right angle. We will put the box on our drawing to remind us this. For us to be able to use the trigonometric ratios, we have to identify the reference angle first. Here, the reference angle is theta, the angle whose value we want to get. Next, we label the side as to opposite, adjacent, or hypotenuse. We will only label the sides with given values. Let's go. Across the reference angle is the opposite side, but there's no value given there, so we will not label that side. Next, we label the adjacent side, the side next to the reference angle. Finally, we label the hypotenuse. We will find the angle measure that the 6.5 feet ladder creates with the ground by solving for angle theta. The result will help us determine if the ladder with the way it is set up is safe for Mario to use. Look at the labeled triangle this time. Of the three trigonometric ratios, which one has the adjacent side and the hypotenuse? You are correct. It is cosine. Now, we write the ratio. So cosine theta is equal to adjacent side over the hypotenuse. Look at our figure and plug in the values given into our equation. So we have cosine theta is equal to 1 over 6.5. Since we are solving for angle theta, we will write the inverse of the above equation. So theta is cosine to the negative 1 times 1 over 6.5. We now solve for angle theta using a calculator. Just like what we did earlier, set the calculator to degree mode. Activate the inverse trigonometric ratio by hitting second, then hit cosine to the negative 1. This is what you will see on your calculator now. Continue by typing 1, hit the division sign, type 6.5, then hit the close parentheses. This is what you will see on the screen of your calculator now. With the image on the screen, hit enter. You now have this value of theta. So theta is equal to 81.2 degrees. Now, is the ladder safe for Mario to use? As recommended, the angle between a ladder and the ground should be 75 degrees for optimal safety and stability. This angle helps ensure that the ladder is secure and less likely to slip. We verified the safeness of the ladder by determining the measure of the angle formed between the ladder and the ground, of which we got a value of 81.2 degrees. With the value that we got, we can say that the ladder is not safe for Mario to use. The angle between the ladder and the ground should be adjusted to about 75 degrees for it to be safe for use. There you are, learners. I hope you acquired lots of learnings in today's video. Let us summarize what we have learned. We have learned that trigonometry is a branch of mathematics that deals with the connections between the measures of the sides and the angles in a right triangle. Second, the ratios of the sides of a right triangle in relation to its acute angle are called trigonometric ratios. Third, the angle measure is obtained by getting the inverses of the trigonometric ratios. The following are the trigonometric ratios with angle A as its reference angle and their corresponding inverses. Fourth, as recommended, the angle between a ladder and the ground should be 75 degrees for safety. Fifth, always set the calculator to degree mode before using it. Sixth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information helps find what you are looking for. Seventh, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye!